Hello, I am Vishesh Patel from Group 4 MG2 and I'll be explaining the real-time video streaming protocol assignment today. Starting from the server.py, when we initialize the server, it starts a sock stream TCP connection on the port given by us in input. On starting the client, we give the server address, server port, RTP port and file name as input. These values are used by the init function to initialize the client. This function also calls the connect to server function, which in turn creates a TCP socket and connects to the server which we opened earlier on the port which we gave as input. The first function we need to call is setup. When we press the setup button, a setup movie function runs. This sends a RTSP request to the server. It increments the sequence number and creates a formatted string as shown with the file name, the sequence number and the port. Next, this request is received by the server by the received RTSP request function. After receiving the request, it is sent to process RTSP request function, which processes the data, gets the required data and creates a video stream object. It also updates the state to ready. It then generates a random session ID and sends OK reply with the sequence number to the client. This function creates a request on the server end, a response on the server end, which is then sent to the client. It contains the sequence ID and the session number. The client receives this acknowledgement by the receive RTSP reply function. After receiving the acknowledgement, it parses the reply, splits the lines to get the data, and as per the type of the request, it updates the state of the client. It also opens a RTP port in case of the setup reply. The RTP port is used to send datagram packets of actual video over the network. As we can see, the socket is of UDT type denoted by sock underscore dgram. So this is the setup function, and now the client is ready to play the video. Now that we are ready to play the video, we can call the play movie function using the play button. This function starts the listen RTP function and also sends a play request to the server. The play request is sent via the send RTSP request function as we saw before. Here the formatting is changed. We send the file name, the sequence number and the session ID with an incremented sequence number, and we also send the play request. This request is sent using the same socket we used before. The server receives the play request and starts processing it. It processes the string, gets the socket port and creates a UDP socket. It sends an OK reply and changes the state to playing. Now it creates a new thread and starts sending RTP video packets to the client. The listen RTP function of the client waits for incoming RTP UDP packets from the server. Incoming data is converted to temporary images which are then displayed continuously in the form of video. This is done by the functions write frame, which creates temporary image files, and update movie, which updates the movie continuously to form a video. The RTP packets sent over the connection are encoded with this header. The header consists of version, padding, extension, sequence number, timestamp, etc. header attributes along with the payload. The payload and the header are sent together in the form of a packet by the getPacket function. Now that the video is in playing state, we can use the pause function. The pause function sends pause request to the server over the RTSP TCP connection. As we saw before, it increments the sequence number and sends the formatted request to the server via the TCP socket. The server receives this request, changes the state to playing, from playing to ready. Now the client is ready to play the video again, but the flow of the RTP packets is stopped for now. The teardown request is used to close the TCP connection. It exits the client. When called, it sends a request to close the connection to the server as seen here. Here we are keeping track of the sent request, which helps us figure out the bitrate. We have calculated the bitrate and plotted it here. The server receives the teardown request and closes the connection. It closes both the RTP socket as well as the RTSP connection which was established before, and sends the OK reply back to the client. The client, on receiving this acknowledgement, calls the handler function and exits the client. The bitrate graph shown on teardown is calculated only when the client is in play state. Here we are calculating the total number of bits received and dividing it by a small time interval to get instantaneous bitrate, which is then plotted in the graph. Let us now overview the working of the system. As shown here, our RTP client does not have a setup button. We have removed the setup button and used the setup function. We have called the setup function when the client is initialized itself, as shown here. On connecting to the server, the setup is done automatically. On playing the video, we receive the bitrates on the client end at regular intervals. This bitrate will be plotted after the video is done playing. We can pause the video at any time. A RTSP request sent and received on the server end is shown here. On clicking the teardown button, we get the bitrate in bits per second. We also get the total received bytes on the client end,